All right, it's time to take a look at a couple more practice questions. I'm a little bit behind. I'm on set 61 through 70. It appears there were 3 questions in this set that caused us a little trouble. So let's take a look at number 63, 65, and 70 for this set. Starting with number 63, this question just tells us that we have a ramp going up to a gym or a ramp into a gym that has a slope of 5%. Now, what a 5% slope means is simply that for every 5 feet of vertical rise, you would have 100 feet of horizontal rise. So your slope, remember, is rise over run. So if you were to look at the rise, you'd have 5 over run, which is 100, and 5 over 100 is 5%. So you can think of that as rise and that as run. So this diagram right here shows us what the ramp is supposed to look like if you were trying to gain 5 vertical feet. The question asks, what would it look like if you were only needing to gain 2 vertical feet? So basically it would have a similar drawing. It would be a little bit smaller because rather than gaining 5 feet, we'd only have to gain 2 vertical feet to our gym floor. It asks what this horizontal distance would be in this diagram. So what I'm going to do is I'm just going to simply use proportions. We have proportionate triangles here. They have the same slope. So I'm going to do 5 is to 100, and that would be from this triangle, as 2 is to x, and that would be from this triangle. And using cross products, we can cross multiply. We have 200 is equal to 5x. Dividing by 5 gives us x is 40. So 40 feet would be the horizontal distance in this ramp. So the answer would be C. Next question I want to take a look at deals with special right triangles, and more particularly it deals with 30, 60, 90 triangles. So if I was to draw this right triangle, we know that this would be the 90. This angle right here is going to be greater, so this would be 60, and this would be 30. Now, the rule in right triangles, or 30, 60, 90 right triangles, says that we have 3 sides, the short leg, the longer leg, and the hypotenuse. Remember, the hypotenuse is always opposite the 90-degree angle. So hypotenuse is easy to identify. The shorter leg is opposite the 30-degree angle, and the longer leg is opposite the 60-degree angle. So we have hypotenuse, longer leg, shorter leg. The rule for 30, 60, 90 triangles says that the longer leg is equal to the square root of 3 times that shorter leg, whatever that is, and the hypotenuse is equal to 2 times the shorter leg. Now, probably the most important concept here to understand, very basically, is that in a 30, 60, 90, all of these side measurements are going to be different, okay? A 30, 60, 90 triangle is not going to be isosceles. There's no way to have a 30, 60, 90 triangle and have 2 of the same sides. So using that concept, we can eliminate this answer because that says they're all the same. We can eliminate this one because it says 2 of them are the same. We can eliminate this one because it also says 2 of them are the same. So just looking at these 2 options, if you remember these formulas, 2 times the shorter leg, square root of 3 times the shorter leg, E is going to be our answer. If the shorter leg in this triangle was 1, as we see right here, then the longer leg would be the square root of 3 times 1, which is the square root of 3. And the hypotenuse would be 2 times 1, or 2 times the shorter leg, which is 2. So those 3 measurements, answer E, could possibly make up a 30, 60, 90 triangle. All right, so in this particular case, it asks us to find the cotangent of angle A. Okay, we probably know that the sine is opposite over hypotenuse, that's so. Cosine is adjacent over hypotenuse, that's ca. And tangent is opposite over adjacent, that's TOA. There are 3 other trig functions that we don't want to forget for this ACT. One of them is indeed the cotangent. The cotangent is simply the opposite of tangent, or the inverse of tangent. So you're going to flip, and you're going to have adjacent over opposite. Okay, similarly, the secant is the reciprocal of this, so that would be hypotenuse over adjacent, and the cosecant, or CSC, is the opposite or inverse of this. That would be hypotenuse over opposite. So basically what we need to do here, since we're dealing with cotangent, that would be this ratio, adjacent over opposite. Here's angle A. This is the adjacent side, the square root of 4 minus x squared over the opposite, which is x. And that is your answer, 4 minus x squared over x, which again is option E. One thing I want to point out with these formulas, I feel like we have a good understanding of this one, and of this one, and of this one. And it's obviously that cotangent is linked with tangent, but these two right here oftentimes get mixed up. They think cosecant should be with cosine, and they think secant should be with sine, just because of these first letters. That is not the case. Realize that these are maybe backwards from what one might think.